So the area under the upper curve is work done. The area under this curve is work done to stretch the material, and the area under the lower graph is the work done to bring the material back to its original length or zero extension, and the area in between here is the minus between both works. Okay, we know that elastic energy is half Fx, okay, where F is the applied force on the spring and X is the extension. For the situation here, we have the force applied on any of these springs is F over 2, because F is applied on both of them, so each one bears F over 2. And the extension is the new length y minus x, okay? So if we looked to the choice, certainly we can choose A, which is 1 over 4 y minus x. Formula for spring constant, F divided by x. So if we have displacement versus distance graph or the wave, and we need how velocity varies with time. For a student who studies A2 level, it will be an easy question because this is a kind of simple harmonic motion, and they know that displacement versus time graph can be used to know the velocity versus time graph, but here is for you as an AS student, you can think about it as the point B will move with the way the wave varies in displacement. I mean, what will go for B now is the downward motion, and then upward motion, and then this is in negative direction, and then upward in positive, and then downward in negative. So we expect the velocity to have same varying direction, because velocity is displacement divided by time or gradient. So for a curve, we cannot expect the velocity to be a constant or to be a bunch of straight lines or to have exactly same shape of displacement with distance, because we are talking about time, and it must be some change. So the answer is D. You can imagine here is the trough part of the wave is going to pass by the particle, so the particle will go down, okay, and it will not go down uniformly with time or forever. It will reach some point when it will stop and goes up again. So particle here goes down, okay, and for at some point of time it will stop, okay, and starts to reverse its direction. More or less, this might be a good explanation for now to you. If we convert this to nanometer, because we know that for visible light, which we can distinguish by our eyes as human, it is from 400 to 700 nanometer. This number is 5,000 nanometer. Okay, so it is correct that it is invisible. Certainly, electromagnetic wave has all types of electromagnetic waves has same speed in free space, which is c, so not different speeds, and it can be certainly polarized. We have light that we saw a lot. How can we polarize it? We have microwave. We went through all these examples of EM waves that are polarized, and it's not consists of vibrating atoms. Vibrating atoms cause the wave, but the wave is mainly energy and propagates in space. So diffraction is spreading of wave as it passes through a gap or around an obstacle. Okay, it's not change in frequency, and it's not confining oscillation to one plane, and certainly not resultant displacement equal sum of displacements of individual waves. This is the uh, superposition. Here we have velocity of source set changes. Okay, as first the observed frequency was 500, and when it changed, server frequency become 250. So we can apply Doppler formula twice. First time it is 500 equal to Fs V over V minus, V positive, because it moves away, V positive Vs. For the second time, it is 250 equal Fs V over V plus again, because it continues to move away from the observer, plus Vs, but this time it will be Vs2 because it changed. We can simply divide this equation. We'll find the left-hand side gives 2, and the right-hand side Fs eliminated with Fs and V eliminated with V, and it is 1 over V plus Vs over 1 over V plus Vs2. We got used to how to manipulate this ratio over ratio by just make the inverse of the second or the ratio in denominator, something like that. Okay, and we can simply make a rearrangement like that. We can get that V plus 2Vs equal to Vs2, which is C. Certainly polarization, sound is longitudinal, and longitudinal has no polarization. As at F there is 2 antinodes, so at 3F there will be 6. We have N lambda equal d sine theta. Here is d 1 over 400, but this should be divided by 10 to minus 32 to convert millimeter to meter, times sine theta. Theta is 1 and sine theta is 90 and sine theta is 1, because question asks about total maxima, times 1 over lambda converted to meter, so it is 700 times 10 to minus 9. If you calculate this, it will give you 3.5, and we will multiply by 2, because when we calculate all of this, this is the grating, and we calculate from the zeros spot to the maximum diffraction angle here, which is 90. Okay, so we should consider the other direction too. So answer is 7. So coherent means constant phase difference. It's not zero phase, by the way, not zero phase difference or same phase. This is a common mistake between students. It is only constant phase difference. Okay, and they need not to be same intensity or same frequency. It's a filament lamp, because as we know, this is an IV graph, and the slope is 1 over r, and as this slope decreases, so 1 over r decreases over r increases, and the filament lamp, its resistance increases with current or with voltage, because temperature rises and electrons make more collision and opposes current. Okay, so from the choice we can't choose B or C, because this is a thermistor, not an LDR. So it is A or D, and if you looked to the position of a meter and compare it with the actual circuit, you will find that answer is A. So we have that power equal to I squared R, and when I is constant, the power is directly proportional to R. Okay, and we know that R is inversely proportional to area, or R squared. So for R2, the thinner section divided by R1, the thicker one, it will be R1 squared over R2 squared, or R1 squared over 2R, sorry, half R1, half R1 squared, which is 1 over 4 R1 squared. R1 squared with R1 squared will be eliminated, and it will give us 4. So power dissipated in thinner lengths of wire will be 4, because as again power directly proportional to R, and R has increases 4 times, so power dissipated in thinner section increases 4 times. So we can multiply current by time. This will give us the charge, and we can divide this charge by 1.6 times 10 to minus 19, and the answer as we have the potential across the 2R resistor is 2, so we can find the current dividing 2 by 2R. It is 1 over R ampere, and this circuit can be simplified like this, where we connect a 4R resistor in parallel with the battery, and also a 6R resistor in parallel with both of them. So 4R and 6R have the same potential as the battery, and as we have the current that flows through the 2R, which is also flows through 3R and R, it is the current flows in this branch or this branch. This current times the total resistance in this branch will give us the potential across this branch, which is again the same as through this branch and as through the battery. So it is 1 over R times 6R. Okay, this gives us 6 volt. So as we close the switch, we increase a resistor to some resistor, and this connection is in parallel. So we have a decrease in total resistance, and this means an increase in current. So current in battery increases with respect to reading on voltmeter. It will be same for the two resistor, but it will not be the same as the case where the switch was open, because when the current now increases, the potential drop across the small internal resistance R increases, and hence the potential out of the battery, which is the same for the two resistor, now decreased. So the answer is A. In beta decay, neutron is converted to proton, electron, and electron neutrino. Okay. Oh, sorry, but this is a positron. So it has an electron. Font size is a little bit small for the zoom. Okay, so it is proton to neutron plus positron plus electron neutrino. So if we start by the polonium 84, 214, after first alpha, it will be some element the 210, 82. After a beta, it will be another element with again 210 and 38. For another beta, it will be 210 and 84. So number of neutrons at the end will be 210 minus 84, which is 1, 2, 6. So for down, it is minus 1 over 3, strange minus 1 over 3, minus 1 over 3, certainly not A. If we go for B, it will not also be a no overall charge, because here is positive 2 over 3, my positive 2 over 3, which is 4 over 3 minus 1 over 3, so it is positive 1. Here is 1 and plus 1 over 3, so it will be D. Thank you for watching. Keep following us.